diffusion section where we type DC based on our parameters. Type D because we're using this. So our diffusion coefficient will be D. So also locate for the convection velocity, and that will be, remember we typed this variable over here. So I'm going to copy this and I'm going to put it in here. Yeah, so that will be the velocity in the y direction. The initial values, I'm going to type C naught. That will be the initial value for this. So in the physics toolbar, let's go to physics and let's add for boundaries and let's add concentration. So I'm going to select boundary. I'm going to select boundary 2. Okay. Select boundary 2 will be the concentration. And species, let's select C. So for our concentration. And we add the flags. Boundaries, we add the flags. Then in the flags, choose boundary 5. Choose boundary 5 only. So our flux is at boundary 5. And move, add, include. We include the, we have the inward flux over here. And let's select the species that we want, and we want to be -R. Okay. Later, everything will be defined. This is because we haven't defined the CS. Okay. So boundaries, you want to add an outflow. And the outflow will be boundary. Let's make it 3. Yeah. Let's go back and let's add a symmetry. The symmetry, we select 1, select 4, select 6 only. Okay. Now we move to the general form PDE. General form PDE. So we are here. So the boundary selection, I want to choose manual. There's selection over here. I want to select boundary 5 only. So we select boundary 5 only. Let's define the dependent variables. Let's custom the units to be mole, meter, and our source term. Let's define it as mole, meter, so, and S in here. As you have in here. GB, sorry, GB. Now, after we've defined the source term and the dependent variables, go to the general form PD E1. Expand the equations. So you have to look at the conservative flux. And we set this as minus CS T X times PS. And this will be CY this way. Source term will be R. Dependent variable has to, sorry. Oh, GB. No, GB. Dependent variable has to be CS. So you realize that when we come here, things has changed. Over here, everything has changed. Now all our definitions are defined. Everything is clear, on point. As you can see, everything is clear and everything is on point here. Okay. So, as I was saying earlier, I wanted us to finish this side. So we come back to the variables. We realize that everything has changed from variables. Our first variable, 1, we go to the geometric entity level. Then we have to select a boundary. So the boundary will be, I think, not 2. Yeah, 5. It's 5. So for this boundary, then we come to variable 2. We choose the domain, and the domain will be 1, as you can see in here. So now that for the partial differential equations, we've been able to set our points. We now go to our initial values. So the default initial value should be 0, yeah. So 0. Initial value is set to 0, as you can see over here. We go to our mesh. Then let's add a free triangle. Right, click the free triangle, add a size. And the size, we add choose a boundary. And we choose 5. And the elements in custom. Element parameters. We choose about the maximum element size, and I want to choose about 1.5. Let's choose about 1.5 micron. Let's build our. Okay, so now that we build our mesh, we go to our time dependent steady. We want to locate the steady settings and also the output times. Output times, you want to make it 2, 0.5. Yeah, I think 2, 0.5, yeah. 0 to 0.05. 0.05. And we'll go ahead and compute. Okay. So now we go to our results. So for the 2D plot group, we have 2D plot group, as you can see over here. So think we can add a line graph. We can add some graphs, plots to this work. So over here, let me first type concentration species in reactor. Let us see. Let's rather. The plots to the plots group. Yeah, so maybe you can even change the time to about, let's say, 15, and we'll see how it will. Okay. That's the concentration species in the reactor. Let's add a 1D plot group. We add the 1D plot group, then maybe we label the side the concentration reactant species along active surface. So let me see the data selection. Okay. The data selection selected. So from this to this, select the last one. Then yeah, we have selected. Now we right click, then we add a line graph to it. And let's select boundary 5. we want to replace the expression over here. And now let's go ahead and just type the y coordinate. The y coordinates. Or you can just go here, go to geometry, and go to coordinates, and basically the same y to y coordinates. We plot a graph. This is the plot of the graph concentration along the, and also we can determine the concentration C, and x-axis could be, expression could be the y. Maybe you can plot like this, and we have a plot like this. This is the concentration along the y-axis. Depending. So over here too, we can decide to select all, then we see for all the various concentrations at different times. This is what we have. As you can see in here. So if I decide to choose the first one, this will be, if I choose the last, this is how the plot will be. And if I choose, so this is the last and this is the first. So let me select the first and last. And let me plot. This is the first and this is the last. So this is how the concentration reacting species along the active surface will be for concentration and along the y-axis. So this is just a simple plot showing concentration species in a reactor and the plot group that we can have. So I hope you're able to follow to this point, because I actually took my time to go through this work. So if you have any question, please let me know in the comment section, and I think I'll see you in the next video. All right, thanks.